Okay, I've had a request to do this question regarding balancing and state symbols. So sodium reacts with water to form sodium hydroxide solution of hydrogen. The equation's been given, and spaces for the balancing and the state symbols which you're required to put in as well. And remember, balancing equations is based on the principle that you have to have the same amount of each substance, so the same number of each atom on both sides of the equation, in order to correspond to the law of conservation of matter. So let's start with sodium, because it's the first one. So sodium here, we've got one sodium on the left hand side, and we've got one sodium on the right hand side. So at the moment they're balanced. We move along, we've got 2 times 2 hydrogens, that's 4 hydrogens on the left, and on the right we've got 2 here and we've got 1 here, so that's a total of 3. So we need to have 4 on the right hand side as well. So usually the problems are caused by the odd numbers, so I generally advise people to start by correcting the odd numbers and turn them into even numbers. So the odd number here is the 1, so to turn it into the smallest even number we have to multiply it by 2. Remember, the only place you can put numbers is at the beginning of each substance. You can't put them at the top, you can't put them at the bottom, you can't put them in between, and so on and so forth. So that 2 now has multiplied all of what comes after it immediately. So you have 2 sodium, you have 2 oxygen, and you have 2 hydrogens. So now you've changed that to 2 hydrogens, which gives you 4 hydrogens in total on the right hand side. And that matches with the 4 on the left. So now let's move on to the oxygens. Or, in fact, we can go back and correct the adjustment that has been made to the sodium, because by putting the 2 in front here, you now have 2 sodium as well. So you have to adjust that and make that 2 sodium. Okay? So now the sodiums are balanced and the hydrogens are balanced. Let's now look at the oxygens. 2 oxygens, and here we've also got 2 oxygens. Okay, so final check: 2 sodium, 2 sodium. 2 times 2 is 4 hydrogen, 2 plus another 2 is 4 hydrogen, and then 2 oxygen and 2 oxygen, and that's balanced now. State symbols are not easy because they're scattered. Learning about state symbols is scattered throughout different topics. It's not something that can be taught all in one go in one nice easy topic. This table is extremely important, okay, because it tells you what kind of substances are soluble and insoluble. All right, so for example, the halides mentioned here, most of them are soluble, but the exceptions that you need to know are mentioned here. Likewise, the sulfates are generally soluble, but these are the 3 exceptions you need to know: barium sulfate, calcium sulfate, and lead sulfate. Nitrates are nice and easy because all nitrates are soluble. So that allows you to figure out, to a certain extent, what the state symbol should be. So for example, when a reaction is carried out in an aqueous medium, in an aqueous environment, or with water, then you know that soluble substances are going to have the state symbols. Another important example: all sodium salts are soluble. So whenever you get a sodium compound being formed in a reaction which is carried out in an aqueous medium, then you know that the sodium compound is also going to be soluble and form an aqueous solution. So back to the equation. Sodium here in its normal state is a solid, state symbol S. Water is a liquid, state symbol L. And remember, state symbols are always lowercase. So you have solid, liquid, gas, and aqueous. Obviously the first three are clear, solid, liquid, and gas. What does aqueous mean? It means dissolved in water, or in solution in water. So water itself is a liquid. As I said earlier, the sodium hydroxide, all sodium compounds are soluble in water, and because this reaction is being done in an aqueous or watery environment, then this will dissolve in water, forming an aqueous solution. And the hydrogen is a gas. Another thing which is worth mentioning is that sometimes, depending on the situation, the state symbols can change. For example, water is usually a liquid, okay? But in the reaction between hydrogen and oxygen, which are used as rocket fuel, by the way, there's an explosive reaction, highly exothermic, to produce water, okay? So balancing, first of all, 2 hydrogens on the left, 2 on the right, 2 oxygens here, so we need 2 on the right, and that's now upset the balance of hydrogens, giving 4 hydrogens here, so we need 4 here. So what times 2 is 4? 2. So the 2 goes there. The state symbols, hydrogen is a gas, and so is oxygen. But when you see a rocket blasting off into outer space, as I said, rocket fuel is a mixture of hydrogen and oxygen. Do you see bucket loads of water pouring out from the bottom? No, you don't. Why? It's highly exothermic, and therefore immediately vaporizes that water produced. So in this case, water is a vapor or a gas in this particular type of reaction. So again, the state symbols can change and can vary depending on the type of situation that you're dealing with.